My name is Scott Lopez, and this is my reference to the OSI model. What does OSI stand for? Well, the OSI stands for Open Systems Interconnection. Alright, so I'm going to give a brief history of what the OSI was, and how it was developed. The OSI model was developed by the ISO, or the International Organization of Standardization, in 1977. What is the purpose of the OSI model? Well, the OSI model was basically created to standardize networking in an effort to make sure that everyone's network would be connected through a common network standard. Now that we have a brief history of the OSI model, let's talk about what it actually is. The OSI model is a 7-layered model used for networking. Each layer contains instructions and protocols to be followed that allows networks to connect with each other. There are 7 layers in the OSI model. Starting from layer 1 and going to layer 7, the layers of the OSI model are the physical layer, the data link layer, the network layer, the transport layer, the session layer, the presentation layer, and the application layer. A friend of mine taught me how to remember this with a simple anagram that you couldn't really mix up with all the other computer terminology. Starting from 1 and going to 7, it's please do not throw sausage pizza away. Let's start with the simplest layer, layer 1, the physical layer. The physical layer is the layer that contains all of the physical components of the OSI model. From pins and cables specification to cables, hubs, and routers. So the physical layer is the layer that actually physically connects the networks together. Simple enough, right? Next on the list of layers is layer 2, or the data link layer. This layer makes it possible to provide a way to exchange data over a common local media. The data link layer provides 2 basic services. One of them is it defines the software processes that provide services to the layer 3 or network layer protocols. The other is it dictates how the hardware performs the media access processes. Next, the data link layer's framing process takes a packet and prepares it for transport through the local media after encapsulating it with a header and a trailer. The header and trailer contain controlling information, such as addressing for the header and error detection for the trailer. Here are some data link layer protocols: Ethernet, ADCCP, also known as Advanced Data Communications Control Protocol, and HDLC, High-Level Data Link Control. And that is the data link layer. Next we have layer 3, known as the network layer. The network layer supplies the means to exchange pieces of data over the network between identified end devices. The network layer implements 4 basic processes. They are addressing, encapsulation, routing, and decapsulation. Addressing deals with the source and destination IP addresses. Encapsulation and decapsulation are similar, except encapsulation happens before data is sent, and decapsulation happens after it arrives at its destination. Routing is the process that takes the packet from source to destination. Think of it like a letter in the mail. The address on the envelope is addressing. Encapsulation is putting the letter into the envelope and sealing it. Routing is the path the mail will actually take in order to arrive at its destination. And decapsulation is when the letter arrives and you open up the envelope and take the letter out. One of the most widely used network layer protocols is the Internet Protocol, such as IPv4 and IPv6. That is the network layer, or layer 3. The next layer is layer 4, or the transport layer. The transport layer provides for the segmentation of data and the control necessary to put together those pieces into the many communication streams. The transport layer uses flow control, segmentation, desegmentation, and error control. Flow control manages the amount of data flow there is. It is used to avoid too much arriving at the device before it is ready. Segmentation breaks the data into pieces so it is easier to send, and desegmentation puts it back together when it gets there. Finally, error control sends requests for resending of pieces of data that didn't arrive. Some of the transport layer protocols are TCP, or Transmission Control Protocol, and UDP, User Datagram Protocol. After layer 4 is layer 5, or the session layer. This layer establishes, manages, and terminates connections, also known as sessions, between two network addressable units. This allows them to communicate with each other constantly without having to find each other every time one sends data to the other, but terminates the session when it is done. Some of the session layer protocols are RPC, which is Remote Procedure Call, RTCP, Real-Time Control Protocol, SMPP, Short Message Peer-to-Peer, and SSH, or Secure Shell. You can almost think of the session layer as a telephone call. When you're establishing a connection, it's like you calling them. When you're maintaining a connection, it's like you having a conversation with the person you called. And when you are terminating a connection, it is like you hanging up the phone on them. Next is the presentation layer, or layer 6. The presentation layer has three main functions. The first primary function is the coding and converting of application layer, or layer 7, data to make sure that the data from the source can be interpreted by the right application on the destination device. The second primary function is the compression of data in a manner that can be decompressed by the destination device. The last primary function of the presentation layer is the encrypting of data for transmission and the decrypting of data upon arriving at the destination device for use. Some of the presentation layer protocols are AFP, Apple Filling Protocol, LPP, Lightweight Presentation Protocol, NCP, Network Control Program, and NDR, Non-Delivery Report or Receipt. Finally, we arrive at the last layer, layer 7, or the applications layer. This final layer supplies the interface between the applications for services we use to communicate in the underlying network. The protocols of the application layer are used to exchange information between programs running on the source and destination hosts. There are actually a lot of application protocols, and there are always new ones being made. And that is the layer 7, or better known as the application layer. After all of that, you have all of the layers of the OSI model. The only thing left to really tell you is that the layers 5 through 7, or application, presentation, and session, are also known as the applications layers. And that layers 1 through 4, or the physical data link, network, and transport layers, are all known as the data flow layer.